thanks for the introduction. Yeah, I mean, she's already introduced so much, so I don't need to introduce myself, and I'll directly start with actually introducing my company, which I'm the co-founder and CEO of, Bright. So at Bright, like typically when you've seen like a lot of startups when we founded use data later in their life cycle. Bright was founded with the core principle of using data and machine learning to change people's lives. And the key problem that we were solving was, we found a lot of, and our market is the US market right now, and we found that a lot of customers, a lot of people were struggling with managing their debt, managing their cash flows, and if you have to translate it into numbers, it results into paying $160 billion of just interest and late fees on credit cards itself. And other debts, it's even more. And that's where we decided from the start, use the data to understand people better, understand their situations better, and then build the decision systems which can actually learn from it and improve their lives, help them get out of debt. So the key things that Bright solves for is we help people pay off their debt. We help them also build savings because we understand their cash flows, and we ultimately also give them a plan to achieve any goal they may have. And just to give you a little bit more insights into why data is so core, we consume data from almost every major data provider in the US, including banks and aggregators. Why that's needed is because it's very crucial to have as good a view of you to make financial decisions for you. So better personalization can be achieved with having a more holistic data view. And that's why we're connected with a lot of partners, about 20 plus partners, both real time and in offline. We have to make decisions which will impact your financial lives. For example, as soon as you as soon as you start, let's say you subscribe for Bright, it will start moving money for you. It's fully automated. That puts a lot of responsibility upon us in terms of what data we are using. Is it correct? What decisions are they accurate? So, yeah, going to the next slide, just to give you an outline of the whole talk, we'll start with a quick introduction to the people who are new to this field in terms of why do you even need to think about data architectures, data storage, data modeling, and then we'll go into prevalent architectures, and then how do you even decide what to use for your company or your business use case. And then post that, what we'll do is we'll go into particular challenges we as a fintech experienced on the problems that we were solving and the kind of solutions that we had to those problems. Yeah, and then post that we can have Q&A. Okay, so first one is why do you even need to, why it's so crucial to have good data architectures in place. So first thing is data-driven decisions. Every B2C company which is acquiring customers online will have that problem of maximizing their ROI, your cost of acquisition versus whatever your ROI, whatever the LTV or your average order value, etc., whatever metrics you track. Good segmentation is key to that. And then data plays a very big role in terms of understanding, figuring and giving the right experience for the right customer. Also showing the right product if you have multiple products. So again, data is very crucial to that, even post facto, in terms of it's powering multiple products like recommendations or logistics or even a cab booking. So again, post facto decisions. So having the data in the right way, in the right format for efficient and fast access is key to making good decisions and getting better business ROIs. Second, obviously, is quite now popular building of predictive models. There are various kinds of AI/ML models that we deploy in business. What we have found to give maximum value is either predictive or segmentation models. There are also inference models that you can build on top of it, which gives you business insights, which can open up new areas for you. So building those, and there you need to ensure that your data is discoverable, so that people can, who have new ideas or who are looking for opportunities or issues, can easily find the right data. Then also it has the that it has the right set of hygiene, and you have the right tools to quickly process. For example, a product manager when trying to access data versus an engineer versus a data scientist, each of them have different sets of skill sets and they need different tools for it. So your ecosystem, for all of them to contribute and incorporate data in their decision making, that platform needs to be there. Then obviously, one thing that's catching up right now very big is it's really costly. The data footprint that's generated right now is big, and the cost of storing, processing is it is significant for any business, and that's where cost efficiency plays a big role. Then obviously, for particularly in fintech or a lot of other regulated domains, security and governance becomes important. How you're accessing users' PII, how you're using their cash flows. You can go into audits, which if your data systems are not well prepared for, will result into spending days just to fix and figure out the right data to give to a regulator, which takes a lot of time away from your product work. So having the systems which can give this data fast enough is again quite important. Then, another thing which everybody does not have all the data themselves. They access the data, lot of data from third-party partners. In today's world, people are sharing data, and that's where integrations become important. And how you are doing integrations, it's again how you're doing integrations and how you're ultimately joining all of that becomes key. So this is like quite a big for us because we integrate on a lot of partners like financial data, activity data, your PII, Euro, everything. So yeah, I mean that becomes critical. So let's go through and look at some popular data architectures, what people go and use. First one is very common and a very old one, data warehouse. The key aspect of it is you have a centralized storage where you are bringing all your data from your application systems in the right format for your business consumption. And ultimately the idea is that this whole central system is designed to have maximum efficiency and speed for your business queries, which are well defined. Where it fails is when you have to do an exploratory analysis. Let's say you want to get some data from here which you never thought that will be useful in future. Now you have to go through this whole engineering cycle of getting this data incorporated here, backfilled if you need to backfill for your analysis, and then it will be accessible for an exploratory analysis for which you don't even know the ROI of. And that's why people move to this slightly newer architecture where they said, okay, rather than fixing what data will be used for data analytics or data science, what I'll do is I'll take the data that's available at the sources and just replicate in my system. And then depending on the use cases, I'll create different views on top of it for different kind of, like if for example someone wants to use exploratory data analysis, they'll have their own set of raw views, etc., which they can, as per need, they can refresh. But they don't have to go through an engineering cycle for that. Similarly for machine learning, and again you can do the same thing as data warehouse, create small data marts on top of it to power your business visualizations, have efficiency, speed, etc. there. Again, the problem that it faces is the end layer is use case based. Now, for the same use case, like let's say if someone is using it for machine learning, different teams in a company, different business units in a company might again use machine learning for different purposes. And the same view may not suffice and it will start conflicting. And again, you'll have to have people to resolve that, or you'll go through that cycle of sanitization. So you lose some flexibility here. That's where people came up with a data mesh architecture where they say, fine, what I'll do is I'll have BU teams own end-to-end. So each BU team will have analysts and if required some data engineers who will build their pipelines and it can be shared across BU teams. Now, this gives a lot of autonomy to each of your teams. For example, your production engineering, sales, marketing, even HR teams, will give them a lot of flexibility to build whatever they want. The problem that comes here is you will need to, again, have that capacity in each team. Each team will need to have data engineers. each team will need to have data analysts. And again, that's a odd problem. Like how will they be managed? You need to have them separate managers in each team. If you don't have a separate manager, then that single manager becomes a bottleneck. So that whole redundancy and the management overhead will become a problem. So in a sufficiently large company, yes, this will work. But if you're trying to apply it in a much more smaller startups, having that many data engineers or data analysts across teams might not be feasible for you. So now I'll go into like what we are using, but one thing which I would like to cover is how do you even decide what to use? And I would model the problem differently. It is not what to use, it's what your problem is. And does an existing solution fit your problem? If it fits, awesome, you can use it. If it doesn't fit, what you can do is you can mix and match. You can understand the reason behind each of these solutions. What are they solving for? And incorporate the right features to create your data architecture, which is more suited for your business use case. And that's what I'll show for our use case. Just quickly going through, these are the key, I just tried to distill what key things I look for, and there can be more. First one is understanding your data use case. So, for example, when I'm starting a business, and unless I have a lot of data to process initially, I will not create a data warehouse. First, like when we started, right, we let all of our analysts actually have a Jupyter notebook directly connected to our application data sources. That helped me understand what are they looking for. It's very hard to think upfront that hey, these will be the kind of data cubes that will be needed for the business analysis. First, you need to understand your use cases. So that's where initially what I do is I don't create any architecture. First, I understand if I don't have enough data to understand, I let them use the direct data. Initially, it might be a high overhead, but you can start understanding, okay, what is the, how much of my use cases are well defined? They are just like fixed data sets that I need to consume for fixed dashboards or analytics, and how many of them are exploratory? Then again, you'll have what frequency I need to refresh the data. Depending on the size of data, your refreshing frequency can be quite costly. And we'll show how it matters for us also. So again, what refresh frequency is required. Also, like what's the recency of the data? For the decision that you are making, is 2 hours enough or even 2 days enough? That might mean different things for your cost. Raw versus aggregated. Again, do you actually need to access raw data? Or 90% of the people are taking that raw data and just aggregating it. So why not just give that aggregated table to all of them? And for the 10% people, you'll figure out a solution, right? Then real time versus offline. And as we were just discussing, we need to make decisions for customers when they are within our funnel, interacting to give them the right experience, show them the right products. We also need to make financial decisions or marketing decisions offline. So again, the breakup of that, let's say if you don't have any real-time decision, it means a very different kind of an architecture versus you have real-time and offline both. Then again, what type of data you have? Do you have a lot of, like for example, if you are consuming from a lot of partners, you have a lot of heterogeneity, you have a lot of JSON files, or you have a lot of JSON fields which you need to add directly. So do you have complex fields, maps, JSON fields, right? So that will require, depending on that, you need to use a different kind of storage. Similarly, velocity. So what rate that data is generated or even changed and how it is changed. Is it just the whole record is changed? Only a few fields are changed. Okay. Again, that results in a different kind of an architecture for you. Then what's the volume that you are handling? Depending on the volume, a different architecture might suffice. A metadata is handled very differently from how you are handling a much larger data set. Then mutability. Does the data change? Particularly in financial domain, the data changes a lot. Like for example, US transactions, US financial transactions can change 60 days post they have been successful. People can mark them as unauthorized or returned, and same thing applies for credit card transactions. There's a duration, even in India, you have such durations for financial transactions where people can come back and dispute those transactions, and that changes the status of your data. And then similar thing can apply to even your attribution data, where like you're acquiring users from a particular, let's say a Facebook channel, and that attribution can be updated post facto. So your data can change or not change
again decides the kind of architecture, and we'll cover some of these actually. Then there are obviously other business considerations. Your org structure matters a lot. Like for example, we saw right, data rate to data mesh was also an org problem that we were solving. We have different BU teams. If you have just one BU team, you will not even think about data mesh, right? So and obviously cost. What kind of cost you can? It's basically ROI. So keeping that data and processing that data, is it actually giving the business ROI? If not, figure out the right balance. And again, last one is regulatory and security requirements. So you have certain kind of governance requirements, who consumes what and how they consume it. So all of that will be there. Challenges we encounter. So first one I already covered. We consume data from a lot of sources. Internal microservices is one thing, but actually consume data from more than 20 partners outside. Be it road data, like let's say social or marketing channels data, or be it even financial partners data like a bank, consuming your bank statement from a bank, or consuming your credit report from a bureau. Or there are sources which will do some kind of fraud analysis for you and generate a bunch of fraud signals, consuming from them. There is telecom data that we consume. All of it can be used for multiple purposes. For example, we use it for multiple purposes like credit underwriting, even figuring out your financial situations, figuring out, let's say, personalization of what kind of a user and what kind of experience will be well suited to you. Then obviously, there are a lot of regulatory and data security requirements. CCPA is very similar to GDPR, which you might have heard in terms of regulations around the BIA accessibility and changing that. Then each data partner that you are integrating with will have their own compliance. They'll say, hey, you cannot keep this data for more than 12 months. Or you can use this data only for these purposes. And all of that you have to meet. Then you have access controls in who can access what data. And it's for us, it becomes really complex because different parts of the company can have access to different data. For example, a customer support representative will have access to your PIA to verify that. There might be, let's say, a credit underwriting team will have access to your cash flow and your bureau data to actually assess the risk for you. Similarly, you'll have cases where the fraud prevention team will have access to everything that you have to figure out the right fraud signals. So again, maintaining the right access controls is quite important, and data retention I've already talked about. Yes, I've already talked about it, financial data changes quite a bit. Then, yeah, accuracy is quite important because I'm making a financial decision for you. If I am initiating a transaction from your account with let's say $100, while the account data is not updated and showing $70, you'll go into overdraft. So I was planning to help you, but I ended up actually causing you more problems. Also, you may, if we initiate the wrong transactions for wrong people may, like the kind of customers that we are dealing with, they may not even have money to pay for some of the essential needs they have. And that's why, again, it puts a lot of responsibility on us from accuracy angle. Then, because of cases like when I'm underwriting you, assessing the risk, fraud, etc., historical data becomes really important. We also do income expense predictions like at various levels. Again, understanding your long-term, short-term cycles of how your expenses are, how your incomes come, that again becomes quite important. So historical data is important. Then we are right now at about 200,000 users, and even at that scale, it's terabytes of data for us. Why? Because per user, the amount of data that we have to consume and process is very high. Because it's all your financial transactions for all your accounts for a large duration, 1 to 2 years minimum. So it's a huge footprint that we have to handle. Also, fintechs suffer from this problem because there are a lot of users have to do a lot of actions to actually start using a fintech product in terms of putting the appropriate PII, even providing some details of their banks, etc. All of that. It's a very high friction funnel. So if you go to your store data, the number of people who are right now subscribed to your product versus the number of people who have touched your system, that ratio will be really, really skewed towards this. So you'll have a huge number of people who have touched your system, but a relatively smaller number of people whom you are day-to-day managing. So if all of this data is in one place, accessing regularly data for people who
are subscribed to your system will have high overhead just because a lot of people touched your system. And you may still want to retain that data because again it might be needed for marketing retargeting. They've filled in their PIA, but they have not added their bank account. Or they have missed just one thing which is pending on confirmation. So a lot of users will be in progress within your system, and that data causes overheads. So these are the kind of problems that fintechs typically face, and we solve some of these. So this is a very high level architecture in terms of how, and it's a very, very high level because each of these internally, I'll show some of them, are architectures in themselves. So essentially, we follow a three-layer philosophy. One is, there's a raw layer. That's basically your sources, your services, which have all those data. We have mostly a microservices architecture. So each of those services will have data. Then we fetch data from third-party partners, which are talking about, which are banks, which are bureaus, telecom providers. So you'll have that. You'll also get data via webhooks, log streams for your in-app activity data, or any other source that you're collecting from. Even marketing channels like Facebook, Google will collect data from that. And in financial world, everything is still catching up. So you'll have people who will be uploading to your literally files to your S3 buckets, and so you have to consume from that too. Now, each of these three layers, what we solve for are a couple of things. One, who owns it? That really helps ensure that reduces the overhead on whoever is consuming it at the next layer. Second thing that we solve for it is it's appropriately separated so that you have flexibility. You let's say whenever somebody at a later view layer wants something for an exploratory analysis, they do not have to go through a very long cycle. So quickly just explaining, the initial layers are very similar to a data lake. So what we do is, from your raw sources, we bring the data to S3 storage, and there are obviously query engines, etc. on top of it. But what happens there is, we decide concepts or entities that are there in our system, and an entity's data might be spread across multiple sources. All of that is brought together, denormalized, and basically compiled into cubes by domain experts. Okay, just missed one point. This, from the raw sources to the cloud storage, that's owned by the respective engineering teams. So if it's an internal service, that team will ensure that they bring the data to the storage. If it's an external provider, there'll be a respective engineering owner for that, who will own and bring the data here. Now, for building these entity tables from this data, denormalizing it, there are domain experts. So we don't let a single engineering team or a single, let's say, analytics team or even a single analyst be responsible for all of it. What we saw was people in our company across engineering or analytics or data sciences had expertise in different entities because they were consuming it for different purposes. So there'll be these people who will have knowledge about 90 or 95% of a user's data spread across the systems. So someone will be responsible for user entities. Someone, let's say engineering, will have much better understanding of the financial transactions data. So they'll be responsible for transactions. Similarly, for each of the entities that you're putting here, you'll have a set of domain experts designated in the company who are responsible for making sure that these cubes are correctly created from the raw data that you're bringing here. And then what we have is, from this time, then we follow a data mesh kind of an architecture. Then each BU team will have either, if they have an analyst, good. Otherwise, they'll probably be accessing shared bandwidth from some other team's analyst. They'll have their own cubes. So for example, for your growth, marketing, you'll have another cube. Credit will have a cube. Revenue will have a cube. And you can create as many. And essentially, whatever they need, either will be in these tables, or the first time they'll do an exploratory analysis to first explore and decide on what they need. And they'll get that created. And then finally, we have superset, which just lets you democratize access to people who are not tech savvy, and Metabase, and there are also Jupyter notebooks here to let you do all kinds of exploratory analysis. So this gave us a lot of flexibility in terms of what's accessible and what they were able to pull. Then let's go to the first challenge that we faced. So first challenge was the data was mutable. As I mentioned, transaction data can change, and
we did get a significant number of changes to the data again and again. Now, and also another thing that we saw was, because I'm connected to partners which are again catching up with the tech world, their systems may fail. They'll be like a bank system or a government system might be down for 2 days, and it's very relevant in India. It can, so you need to be prepared for such situations in terms of how you're accessing and changing and backfilling data. You may have some partial status and now it failed. So you need to get back and update that. It might have already gone into your warehouse or a data lake, whatever you're using. So solutions for that. Now, one possible approach which is naive is what you can do is you can just create a copy of whatever you're updating, update that copy and replace. The problem is, pros is it's simple, it's trivial, but it's expensive to write. Even if just one record was updated, you have to take a copy of the whole thing and change that and replace it. That's quite expensive if you are receiving only 1% or 0.1% of the data has changed, right? And now multiple people might be accessing that data, or multiple services or sources will be writing that data. So you need to acquire logs for that. As soon as you do that, it will cause failures. So the other approach, which we have taken, and I'll explain a little bit variation of it, is we say file is not rewritten, but I'll actually go here itself. So what we do is, we write updates to separate small files. Like there can be an update file or a delete file, where you are just, for today, whatever deletions or updations that you got, just put it into those files. Now, anybody who's reading it, they can, at the time when they are reading it, they apply either if it's Spark in memory or if it's Hadoop in later stages, they'll apply the changes and then have the final data set which they'll use for whatever consumption that's needed. The problem that you'll face here is this will grow over time, right? And that makes your ultimately reads heavy, because your read process of applying these changes can become quite heavy. Simple change for that which we do in this whole thing is do regular compacting. So depending on the kind of change, depending on how heavy it becomes with your changes, you can apply periodic compacting jobs which will take it and replace this data with the applied data periodically. Cool. I'll go to the next use case, which is efficiency and speed of access. Now, the biggest piece of data among everything that we consume, and which is where a lot of our architecture and problem solving goes, is financial transactions data. So people can have 4 to 8 accounts with us. Each of them will have transactions that you have done for the last 2-3 years. Now, different use cases, I need to access that data for different periods. For example, for getting your balance history, or even for finding some recent fraud you may have done, or even incrementally incorporating your data into some model that I had built, I need last few days of data for all recent users. Similarly, for underwriting, I need as long data as possible, because that gives me what kind of a behavior you've had over time, apart from the bureau signals. So similarly, again for machine learning models which we use for income expense prediction, I might again need 9 to 12 months of data. So for the same set of data, I have different use cases. I'm consuming different periods, different sets of users, and this data is itself runs in terabytes. Just the transactions data. It's huge because it has all your transaction information that's there in your statement. That's why, again, architecting this is quite important. There are a couple of other things that contribute here: top of the funnel versus lower of the funnel, support for rerun of jobs, etc. Like whenever we have to backfill, that also needs to come in there. So, yeah, how do we solve this? I'll directly come to this. So what we do is we partition it into 3 parts. I said one partition will be current month, 12 months, and previous years. Different partition, depending on the kind of access that is there, will have a different kind of, let's say, file aggregation. For example, you can see current month, I may need data for recent users. Because of that, processing date becomes important, which is a concept when this user came into the system, not when the transaction was posted. But for example, let's say for income expense predictions or machine learning models that we are building, I may need your monthly data for last n number. I might just need these particular months. So I have a monthly partition but it's only for last 12 months because I don't need 90%, 95% of my access is not beyond that. And then for previous years, I may need the data for underwriting, but I take all of that data in one go. I don't need it for particular months. So the partitioning is different. Now, the problem that happens here is someone who's consuming has to decide where do I pick my data from, and every person who's writing a job will have to put in those clauses. So for that, the simple solution is put a Hive view on top of it, which will aggregate and which handles, so depending on your query parameters, it will direct you which data to choose from. So for you, it's, I'm just accessing this data, but it's efficient, it's fast. Cool. Last one is, we have 3 problems around heterogeneity. I can take 4 or 5 minutes, right? I'll take the questions off. So, first one is, let's say I'll take you through this example itself. So, any financial transaction that let's say I'm initiating a transaction to pay down your debt or paying a bill. Now, that itself will have a footprint across 3 systems. The system which is taking the decision. The system where we have our own payment systems. So, it has its own state machine and statuses, etc. So, you'll have a status there. And then you'll also want to know if the status is reflecting in users' bank statements, because that's where user sees it. That, okay, these guys have actually paid my credit card. So, sorry. Yeah. This will have data across 3 systems which needs to be taken. Now, the problem that happens is each of these systems might be at different stages. It's not all of them are in sync. So, the timestamps are different, and even the statuses might be different. Some might be more recent than the other. And when I'm analyzing, I need the data, let's say, for all 3 in one place. The problem that happens is I don't know which is like how recent it is or which status is stale or not stale. So that causes problems, and they have to write their own logic of consuming and building that. What we did was simply add a timestamp as a field, which is also propagating to the last one, and also weights. Another thing which can happen here is the same data might be occurring in multiple places. But you have to decide, somebody who's consuming has to decide which data, like the same field, which source I should take it from. So the weights help there, and the timestamps help in terms of checking what status is stale or more recent. What now, the person who's consuming this can easily build a view on top of it. Like they can say, hey, for my business use case, I just want the most recent one. But another person might say, for my business use case, I don't care if it's recent, I want to know the payment transactions statuses. So yeah, this solves this problem of data from different sources lagging or being ahead of others, and also taking and merging the same data from different sources using weights. The last one is, this problem is quite interesting, where now we have to collect data from a lot of sources. Each of them have their own schema. Each of them have their own naming convention. Each of them also have their own way of pulling the data. Now, the downward decision system, a data scientist building a machine learning model, doesn't have to worry about this data is coming from a bank or a financial bureau. They need that the same field, like let's say credit card balance, can occur in a bank statement, can occur in a bureau data for you. And all of that needs to be unified. So that's where we have a generic structure which we follow for all partners, where you actually have a layered architecture, and this is both for offline and online, like both for batch and real time, where the data flows from your providers, gets cleaned up there because each of them have their own hygiene problems, mapped to a unified schema, where we have a metadata service to give the metadata that is required for mapping. And then it comes into the core tables, which will have validators, and we have validators at different levels which take care of hygiene, etc. Which will have validators to check if it's correct, etc. If not correct, how to correct. And then ultimately it goes into, is this clear? I guess it's not clear enough. Okay, but this says entity manager, and then it goes into, because the same thing from different sources is corresponding to the same entity. So the end business user is consuming the entities. So now it goes through all that mapping and cleaning process to just provide one single layer of entities for end business use cases which do not have to worry about if this data is coming from 10 sources or one source. They can just utilize all of that to bring the best value for their particular use case. So then you have your BU product layers, ML models, app services, decision systems on top of that to achieve the required use case that you have. That's it. Thanks everyone. We do keep, like, we are growing all this, and we are interested in anybody who's passionate about data science, AI, ML, data engineering. So these are my contact details. You can reach me here, and if you have any questions, I can take off.